Alright, so welcome back again, and this is the Chipmaster, and in this video I will be doing another laptop repair, and that's a MacBook. Right, so I got a MacBook from a tech and he said that it's not turning on. I got it in this bag as is. Right, so it's a A1990 MacBook Pro A1990. It's a 16-inch space gray MacBook. Alright, so I'm gonna plug in the charger now to see what the current consumption is like. I hope it's not that cap shorted on the edge of the board, which is a signature failure. Alright, so I'm gonna plug in the power. Alright, so as you can see there, I have 19 volts and the current is 64 milliamp. It's actually turning on. As you can see, I'm taking 18 volts there. It's on. Well, I'm trying to, yes, check in. So I'm pressing the touchpad and it's actually turning on, but I'm not seeing anything on the screen. The touch bar is not lighting up, as you can see. Right, so there's nothing on the touch bar. Right, the touch bar is not lighting up. And it's taking 670 milliamp there, 700 milliamp. It's not turning on. I'm not seeing anything, but it's actually on. It's actually on. So I will do a disassembly right here. Right. Alright, the battery is swollen, as you can see, and there's a lot of dust. Let's do an examination, inspection on the board. Alright, so as you can see over here, we're all good. Here on the backlight circuit here, it's all good. Right at the T2 section here, it's pretty good. There's no liquid intake, just dust particles that are on the board. Okay, Alright, so I will continue with the disassembly process. Alright, so I'm now gonna take out the board. Alright, the board is out. I'm just scanning the board on the other side. Alright, so let's take a look at this section as well. Alright, so this side is also good on the power delivery chip here. Alright, this is the cap that is normally cracked on the edge of the board here and causing that PP bus to be shorted. As you know, on the edge of the board here, which is the danger spot, a common flaw or a design flaw. Looking on this side, as you can see, just some dust. There's no any form of liquid intake, any burner, any explosion there. Right in the section here of the board, all good, all good, and it's all good, as you can see. Just dust. Alright, so I'm just going to clean the dust off the board. Alright, so I've now cleaned the board. So I'm going to connect the adapter. Alright, so now I've connected the DC jack. Zoom out some more. Alright, so first I'm going to check some resistances. First thing I'm going to check for is the SSD power supply area, because that's where the UEFI lives, inside one of the NANDs. So if the NAND dies, or if one of the NAND had a short, then the UEFI is what allows you to get the DARM. So each time you press the button or you turn on your MacBook and you get that DARM, that's the UEFI starting up, right? So and that UEFI lives inside of the SSD, because there's no more BIOS chip. This is a T2 based board. As you can see, this is an Apple Silicon T2 base with an Intel CPU, right? And there is no BIOS chip or 8-pin EEPROM SAPROM chip, right? So it's lived inside of the T2. So the T2, when it is restored from the factory with the iBoot, the UEFI is installed inside of one of the NANDs, right? And then the other NAND stores the data and the operating software, which is their macOS, right? So as you can see, we have a set of NANDs here and a set of NANDs here, right? So that's a total of 4 NANDs. So I'd have to peel off the sticker to see the size of the NAND to calculate how many storage is there for the SSD drives, right? So as I said before, the UEFI lives in one of the NANDs, right? And the other NANDs store the macOS and your data files, right? Because there's no BIOS, right? Normally on the older MacBooks, the UEFI is stored in the BIOS ROM, right? So, but there's no BIOS ROM, so it is stored inside of one of the NANDs, right? Because the T2 chip has replaced the BIOS chip itself, right? And it's now inside of the T2, and that is now sent to a designated area reserved on the NAND, which is their UEFI, which allows your computer to turn on and DARM or chime, and that's what is that process of doing the whole booting process with the iBoot, right? The iBoot is stored inside of the T2 ROM. All right, so let's check this section here. Let's go under the microscope. All right. Oops, turn off the lights. Alright, normally this area are normally shorted. If the NAND is shorted, then that's kaboom. All the data is gone and the UEFI has lost its home. So let's measure here. And I get a short. You see that? So the UEFI is dead. So the UEFI basically lost its home, and its home is reserved in one of these NANDs, as I said before. As you can see here, we have a Toshiba NAND here, as you can see. Let me see if you can pick it up under the microscope. Right, there we go. Let me see if I can focus. So as you can see, it's a TSB, right? And it's a 3227, right? That's a Toshiba. These are proprietary NANDs, right? Which are created, they are designed by Toshiba. And you can't get these to buy because they're proprietary. So they're owned by them. So you have to take them from a donor board in order to get these replacements, right? As you can see here, we have a TSB 3227, right? And that's a 128, right? So that's a 128, 128. And the next side, we have another set here. Let me see if I can focus because of the writing is on a black background there on the chip. So it's kind of a bit challenging for me to get it to focus under the microscope. Let's try again. As you can see, we have a TSB 3227, and that's another 128, right? And the other one at the top here, it's the same. So that's 128, 128. So it's a total of 512 gigabytes of storage, right? So that's 512 gigabytes of storage. And we have a short on the rail. So this section here, as you can see here, for the NANDs, we need roughly 3 supplies. Three main power supplies, which is 2.5 or 2.7 volts. 2.5 volts, 2.7 volts is for the T1 baseboards, such as the A1706 and the A1707s, right? So this is PP 2.5 volts. This section here is 0.9, and this section here is 1.8. So as you can see, these two coils are connected together. Not? Yes, as you can see here, these two coils are, let me turn off the light. Right, so as you can see here, these two coils are connected together, right? And that indicates they're in parallel. So this is 1.8, sorry, and this is 0.9. So I'm going to check those other coils, right? I'm starting to worry because if the NANDs are fried, then the repair is kaboom. I'll have to take these, search for donor boards to take these NANDs off one by one, and have to replace all of them, right? And that's the nightmare of doing a NAND repair. Alright, so I'm going to check the 1.8 rail. As you can see, I get 259, right? Excellent. I'm going to check the 0.9 volt rail, and it's 325. As you can see, this is the Corona chip. This chip is called the Corona chip, right? Which is sending the power supply to the 0.9, and it's also controlling the 1.8 supplies, right? and this is the TPS 62180. We call it this. We call it the. I call most people call it nightmare ICs because this MOSFET normal. This chip has two MOSFETs inside, and they break, and they normally send the 12 volts to damage the NANDs, right? So this is a common flaw with this chip, right? So it's a TPS 2180, right? And this chip has a integrated MOSFET. It's a PWM buck converter IC, right? And it is supplying 2.5 volts here. As I can see, it's shorted here, right? It is shorted. So could it be that the NANDs are fried, or could it be that there's a shorted cap on this slide? So let me turn it over. Normally, these caps normally break, as you can see here, right? This is supplying. These are the filter capacitors for the PP 2.5 volt rail, and one of them always normally crack and break, right? This resistor here is for a compensation, and it can also act as an enable to talk to the TPS 62180 and also serve as a bias compensation for the T2, because the T2 has the SSD controller that is inside of the T2 chip, which is communicating to the CPU or the PCH. Here is the Intel PCH, and it is connected to the PCI Express 4 speed lane, right? So this is a PCH, right? This is an Intel chip, as you can see. Let me see if I can focus. Right, so it's SR40F. As you can see, this is an Intel PCH hub, right? This is also having a PCI Express 4 speed communication, which is communicating with the T2 chip. So the T2 chip is basically managing the SSD, as you can see, not the hub, right? The hub is not managing the SSD chips, right? It is controlled by the T2, right? And if I remove this plastic, and this is the T2 chip. This is a powerful chip. So I'm removing as you can see, it's the T2 chip there, and this is a proprietary chip, and it is owned by Apple. As you can see, the Apple logo is there, right? And this is a 1 gigabyte. As you can see, it's a 1 gigabyte. So that's D9VLN, and that's indicate this is a 1 gigabyte of RAM or SRAM. This is the RAM on top of the chip. Under the chip, it's a two-layer chip. So under the chip, there's another chip, which is the actual T2 RAM, actual T2 chip. Sorry. So this is D9VLN, and that's a 1 gigabyte. So if this is a 1 gigabyte, that means the maximum amount of SSD storage that can be stored on this is 512, right? If it has a 2 gigabyte T2 chip, then you can upgrade up to 8 terabytes of storage, right? This MacBook cannot be upgraded to 1 terabyte because it only has 1 gigabyte of T2 SRAM, right? So the SRAM for the T2 is only 1 gigabyte, as you can see, and that's, let me repeat, that's D9VLN, and that indicates that this is a 1 gigabyte T2 chip, and it's only able to accommodate 512 gigabyte maximum or 256. So anywhere between 128 to 256 gigabyte to 512 gigabyte can be interchange on this. So I can downgrade. So I can downgrade this to a 256 and it works. I can downgrade it to a 128 and it also works, right? But I can't upgrade to a 1 terabyte because it only has 1 gigabyte of T2 SRAM, right? So I'm going to check these capacitors here. As I said before, because this is a common flaw on the board here. This is a common flaw on the board here, as you can see, where the board has the ventilation here, right? That ventilation here on the side here, as you can see, dust, liquid, all kind of debris and corrosion tend to come on either side of the board here, right? Either side of this board, either this side or this side, right? So any side is prone to dust and liquid intake, which can cause damaging to the to the SSD or to the SSD power supply chip, or to these capacitors here that are supplying 2.5 volts for the SSD. So I'm going to, so these caps here, let me go back under the microscope. That's what I should have done. So these caps here, as you can see, this is a signature problem, because the UEFI is not, the SSDs are not powered, so the UEFI cannot boot, as you can see. So let me dust off here. This side is a troubled side. As you can see, this cap here is about to crack, so I'll have to remove it. If I don't remove it, then within another month or so, this is gonna crack and the laptop will be completely dead. So I'm just removing the excess dust right here. As you can see, the excess dust is right there, so let me remove. Alright, so as you can see now, I'm looking at this capacitor here and it looks like it's cracked. Let me see if I can get a proper zoom. Alright, there we go. I don't know if you can see, but if you can see that there's a white, so you can see that white, that's a crack. So this cap is bad, right? That cap is cracked there. So I'm going to get the soldering iron and I'm going to remove it. So you see, this is a signature problem, as you can see, with most Apples, with the design of that ventilation there. Very poor design, causing heartache for their customers and their end users in the long run. So let me remove. So I'm just going to lift one leg of this capacitor here. Alright, so I'm just going to lift one leg, as you can see. There we go. Oops, I didn't get it. One more time. There we go. So I lifted one leg. Alright, so I'm going to check now at the coil, PP 2.5 volts coil. And that's here. Let me zoom out a bit. As you can see, the impedance is now restored to 335. So now the UEFI has its house back, so it can live, and the NANDs are getting powered. So in order for the NANDs to be powered, the UEFI needs its home in order for it to start living again, and your laptop will be functional, right? So this is a common issue, as I said before. So I'm just going to remove this cap here. And then I'm going to replace this one as well. This one is going to crack anytime. That's removed. Let me remove this as well. This is a 0603 capacitor, PP bus. There we go. So I removed it. It's tinning it now with some lead, some fresh leaded solder, and it's one as well. There we go. Nice and shiny. This one is actually lifting. Just adding back some solder back to the joint there. There we go. Inside. Alright, so now I will clean it with some 99.9. we go. So now we'll now replace these two capacitors, 0603 and a 0402 capacitor. Alright, so now I have a 0402 cap, so I'll just install this one first. So I'm just adding some flux. Alright, there we go. This section now. Alright, so this is a 0603. Alright, there we go. Alright, so I now clean the board. Okay, so I will now check if I'm getting the correct voltage now. Plug it in the adapter. See if I get in 2.5 volts. Yes, and I get 2.5 volts. As you see, the current is now increased. Before it was at 900 milliamp. As you can see, I'm now getting 2.5. I now get 0.9. Oh, okay, and now I should get 1.8. Right, so 1.8 is there, as you can see. Right, 0.9 and 2.5. Right, so it's now restored, and the UEFI has its own back, and it can say, hey, hooray, I got back my home. My home was burnt down, or I lose my home, so I got it back. So the UEFI can now initialize and chime, and you can now access your macOS and their data files. Right, so as you can see, that's how the process works. Yeah, sorry about that. So I will now put the unit back together and see what I get. So I'm going to pause because of time. So I'm going to connect all the parts, assemble back the unit, and then do the final test. Alright, so I'm basically at the end of the assembly process. Just connect the battery. Alright, just double checking, make sure that everything is intact. Alright, all is intact. Alright, so let's see if it can turn on the battery. The battery is swollen, so I'll have to connect the power. Alright, so it's now boosting to 19 volts. As you can see, the current is now 700, 800, 1.4, 2 ampere. And we have apples. So the UEFI got back his house, as you can see. There we go, we have Apple logo, and we have display there. We are now on to the we are getting 3 amperes, so the battery is charging 3.26, so it's charging very well. Right, so as you can see there, we have a successful repair there. So that is a common flaw with these MacBooks. As I said before, the edges of the board having the ventilation of the for the exhaust, and it also traps a lot of dust and any form of liquid. The spill, that's the first place it's going to catch, damaging the SSDs and the TPS 62180 chip and causing all kinds of problems. Alright, so I hope you enjoyed the video, and I hope you learned something. And as again, in the next video, I will prepare something for you in another video. Okay then, thanks for watching. Bye. Please like and subscribe as well, and let me know what you think about this video and what you have learned and what you're not clear on certain topics that I've talked about. Alright, bye.